Welcome to section 7.4. So now we're going to continue on with what we started in 7.3, and we're going to actually add and subtract rational fractions, or rational expressions rather, now that you know how to get common denominators and so on. So let's review by doing another example with fractions again first. Alright, so let's say we want to add 3/5 and 9/7. So first you need a common denominator. Okay, so I'm going to need to rewrite each fraction so that they have the same denominator. Well, before we can do that, we need to figure out what is the lowest common denominator. And between 5 and 7, since both of those are prime numbers and they don't factor, the lowest common denominator must be the product of those two numbers, 5 and 7. So it must be 35. So we can make a note of that. The lowest common denominator is 35, so we need to rewrite each fraction so that it's over 35. So the question is, what do you multiply this 3/5 by in order to get a denominator of 35? Well, the answer would be 7 over 7. That's again a fancy form of 1. Okay, I'm just multiplying a number by 1, the 7 over 7 is, but it will change this denominator to 35. And the second fraction, 9 over 7, to get a 35 down here, we need to multiply it by 5, so we can multiply the second fraction by 5 over 5, another fancy form of 1. And then multiplying the fractions, we get 21 over 35 plus 45 over 35. And then we can add those. Let's see, so we would have 66 over 35. And then after you add or subtract, you want to see if anything simplifies further. 66, here's my quick division method, breaks down into, I always divide by small prime numbers, so I'm going to divide by 2 to get 33. Well, that divides by 3 to get 11. Okay, and 35, let's see, we can divide it by 5 to get 7. And this right here, what you're seeing along here, that's the prime factorization of 66. That's the prime factorization of 35. They have no common factors, so nothing else is going to simplify. So that is the sum of those two fractions in simplest form. Okay, so here are some steps broken down. This is from your book, but these are pretty good steps. It's to first find the lowest common denominator of the two rational expressions, like we did here. Then rewrite each rational expression as an equivalent expression whose denominator is the lowest common denominator found in step 1. So that's how we rewrote the first fraction. 3/5 we rewrote as 21 over 35. And then we rewrote 9 over 7 as 45 over 35 by multiplying by the fancy forms of 1. That's step 2. And then step 3, you actually add them. And step 4, simplify if possible. So let's do a few practice problems on this. Okay, actually I'll leave it where you can see those steps for now, but make sure you pause the video and write those down and try each of these examples, of course, without me, and then restart the video to see if you got it correct or if you get stuck, to get help along the way. Okay, so on this first one, we want to subtract y over 5 and 3y over 15. So we need a common denominator before we can subtract between 5 and 15. Now this one's simple enough, you can really just do it in your head. The lowest common denominator between 5 and 15 is going to have to be 15 because 5 is already a factor of 15. So what we need to multiply is the first fraction. We need to multiply it by a fancy form of 1. So the y over 5, I'm going to need to multiply it by 3 over 3 to get a 15 in its denominator. And then, oops, that should say minus. And then the 3y over 15 doesn't need to be changed at all. So then we'll have 3y over 15 minus 3y over 15. Now isn't that an interesting example? 3y over 15 minus 3y over 15, well those are the same factor. So you actually just get 0 in this case. Okay, let's do another one here. 5 over 8x plus 11 over 10x squared. This one's not as obvious what the lowest common denominator is. So between 8x and 10x squared. Now let's do the x's first because that's the easier part. We have 1x here and we have 2x's over here. So it's going to have to be some constant times x squared. The question is, what is the constant? In other words, what is the lowest common divisor, or lowest common multiple of 8 and 10? So let's go, oh, this is scratch work here. Going off to the side, okay. 8 breaks down into 2 cubed. That's its prime factorization. 10 breaks down into 5 and 2. So the lowest common multiple of those two numbers, let's see, we need at least 3 2's. That covers all of our 2's. And then we need at least 1 5 to cover that 5 there, which would be 8 times 5, which is 40. So our lowest common divisor will be 40x squared. So it's the lowest common multiple between 8 and 10. Okay, so what do we need to multiply this first fraction by in order to get a 40x squared in its denominator? Well, we need to multiply the 8 times a 5 to get 40. So we're going to have a 5. And the x needs to be multiplied by one more x to get that x squared. So 5x over itself. And the second fraction, 11 over 10x squared, it needs to be multiplied by, let's see, 10 needs to be multiplied by what to get 40? Well, that would be 4. And x squared needs to be multiplied by what to get x squared? Well, nothing, just 1. So we just have times 4 over 4. Okay, so then multiplying these, okay, that's scratch work, so I'm going to box that off. That's scratch work, box that off. Okay, just to keep my work clear, and I recommend you do the same thing. Okay, now let's multiply this together. So on the first fraction, multiplying numerators here gives us 25x squared over 40x squared. And over here we'll have 44 over 40x squared. This is good because they have the same denominator, so now we can add. So we have 25x squared plus 44 over 40x squared. Okay, so there is the sum. Next question is, does it simplify? Well, the x squareds, of course, don't cancel because this is not factored. We have a plus. So before we could cancel anything, we would have to factor this numerator. So the only way to do that would be to factor some common number out of 25 and 44. However, 25 breaks down into 5 times 5, and 44 breaks down into 2 times 2 times 11, so they have no common factors. So nothing factors out of the numerator, so that is the simplest form right there. Okay, let's working another one here. We need to get the lowest common denominator between x squared minus 9 and x minus 3. Well, in order to see what factors they have, we're going to have to factor each of those in order to get the lowest common multiple of those, we get the lowest common denominator. And if we factor those, so again I'm going off to scratch work on the side here, x squared minus 9, that is a difference of squares, x squared minus 3 squared, so it factors into x plus 3 times x minus 3. And x minus 3 is factored, that's as simple as it gets. Now they do actually already have one common factor here, and that is x minus 3. They each have that. So the lowest common denominator is the product here of each factor. So x minus 3, that by putting it here once, it accounts for both of them. And then we'll need an x plus 3 to account for that one. So it's the product of the two. So what do we need to multiply the first fraction by to get this in the denominator? Well, nothing, because that is the denominator. X squared minus 9 factors into x plus 3 times x minus 3. And on the second fraction, though, we only have 5 times x plus 3. So we need to multiply it by something over itself to get this in the denominator. And what it has is an x plus 3, so what it needs is an x minus 3. So we'll multiply this one by x minus 3 over x minus 3. And now let's multiply that through. Now what you may want to do here, after you recopy the first fraction, is to multiply, or I'm sorry, add parentheses here and here, because if you don't, you might forget that the 5 really distributes to the whole thing, and this x plus 3 is all times x minus 3. You really have to FOIL there. Although there is no need to expand that, I am going to go ahead and multiply out the 5 on the next step. How about 5x minus 15? There's no reason to multiply out that denominator because after we subtract, we're going to want to refactor it anyways to see if something cancels. So now let's go ahead and subtract. So we have 10x minus, remember this whole numerator, it's minus everything here, 5x minus 15, all divided by x plus 3 times x minus 3, which gives us, let's see, before we can simplify, we've got to simplify or before we can cancel factors, we must simplify the numerator. Well, to do that, we need to combine like terms. So we do need to distribute this minus so that we can combine the 10x and the 5x term. So we have 10x minus 5x plus 15 all over x plus 3 times x minus 3. Well, 10x minus 5x are like terms. Those add to 5x. We have 5x plus 15 over x plus 3 times x minus 3. And so we're still now looking for things that simplify. But if you look at the numerator, we still have to factor first. It's not factored because we have a plus here. But we can factor out a 5 of both terms. So if we do that, we'd be left with x plus 3. And then these cancel, x plus 3 over x plus 3, so we get 5 over x minus 3 as our final answer. So that one took a lot of work to get there. So as you can see, it's important that you be very organized with your work, as I've said many times. And when you write two things, when you simplify, make sure you put an equal sign in between each step. Okay, you can work your work all vertically down your page, down in columns, or you can do what I do, which is a bit of a combination of both horizontal. So here I've got two steps going horizontally here to here, and then I continue on to the next line down here to here and here. It doesn't matter how you do it, what order, as long as it's very neatly organized so that you can follow your work and I can follow your work. Now oftentimes you're going to make mistakes, and if your work is organized like this, you won't have to start completely over every time you make a minor mistake. All you'll have to do is re-look at your work and check your steps until you find it. Okay, but being organized will help you to find your mistakes as well. Okay, let's do another example. So we want to add 5 over 7x plus 2 over x minus 1. So the question is, do 7x and x plus 1, between those we need the lowest common denominator. So do they have any common factors? And I can tell just from looking at it, there's definitely no common factors here. There's no way to factor anything out of x plus 1, and there's no way that x plus 1 is going to be a factor of 7x. So the lowest common denominator must just be the product of the two, because these are essentially like prime numbers, sort of like the one we did up here, between 5 and 7. There were no common factors between 5 and 7, so we just multiplied them together to get the lowest common denominator. So same thing here, the lowest common denominator will be their product. So we need to multiply the first fraction, 5 over 7x, times the other fraction's denominator over itself, so times x plus 1 over x plus 1. Then we have plus 2 over x plus 1 times this denominator over itself, so times 7x over 7x. So multiplying, remember add parentheses if you need to, because this is really 5 times the whole x minus 1. It's not 5x minus 1. That's not right, or plus 1. It's 5 times the whole thing, x plus 1, all over 7x times x plus 1. So let's add these parentheses in everywhere here. Plus 2 times 7x, that'll be 14x, over 7x times x plus 1. I'm just going to reorder those. Well, this is good because now we have a common denominator, 7x times x plus 1. So now we can add the fractions. So we add the numerators. So we have 5 times x plus 1. And let's go ahead and expand since we're going to need to anyways. That's 5x plus 5. Then we have plus the 14x all over 7x times x plus 1. Now the reason I knew we'd need to expand that 5 out is so that we could combine it with this 14x and simplify as much as possible so that we can then simplify the whole thing from there. So 14x plus 5x is 19x plus 5. over 7x times x plus 1. That's a 19 there. And it's not, the numerator is not factored, however, we can't factor anything out of 19x plus 5. So this is fully simplified sum. Okay, let's subtract two fractions here. Here we have 10 over x minus 6 minus 15 over 6 minus x. And let me remind you again, if you haven't been doing it, make sure you're pausing the video, trying each one on your own first. That's the best way to learn. And then watching me do it. Okay, so we need to figure out what is the lowest common denominator for x minus 6 and 6 minus x. Well, we did one like this in the previous section because 6 minus x is very similar to x minus 6. All you have to do is factor out a negative 1 and you'll get negative 6 plus x, which is the same as the negative of x minus 6. These are really the same denominator. They only differ by a negative. So let's just rewrite this one. Okay, because negative 1 is easy to play with, I'm going to rewrite this one a little bit. 10 over x minus 6. Now this denominator, let's just rewrite it how I rewrote it down here as the negative of x minus 6. Now to get a common denominator, I could multiply the first fraction by this negative 1 over itself, or I could just simplify it as is here. We have minus a negative. That's the same as adding. So this I can rewrite as 10 over x minus 6 plus 15 over x minus 6. And now they have the same denominator. So we can add those two fractions. 10 plus 15 is 25 over x minus 6. So there's that one. And let's do another one here. We want to add 2 to x over x plus 5. Well, this is different because 2 is not a fraction, but we can rewrite 2 as a fraction if you want to. Just write it as 2 over 1. Okay, so what is the lowest common denominator between 1 and x plus 5? Well, it's just x plus 5. So we'll multiply the first fraction by x plus 5 over itself. And I'm going to go ahead and multiply it in without writing it as a separate fraction here. We have plus x over x plus 5. And so then we can add the two fractions. So we have 2 times x plus 5. Distributing that 2, we have 2x plus 10. Then plus this x all over x plus 5. Which gives us, let's see, in the numerator we can add this 2x plus x is 3x plus 10 over x plus 5. And then neither the numerator or denominator is factored, but we can't factor a 3 out of 10, so this is its simplified form right there. Okay, let's do another example here. We need to find the lowest common multiple between 3x squared plus 2x and 12 plus 18x. Now that's somewhat long, so I'm going to go off to the side here and factor each of those. You know what, actually I'm not going to do that. I'm going to show you how to do it in your work so that you don't have to use scratch work to do it. Let's just rewrite this here factored. Okay, so 3x squared plus 2x. We can take an x out and we'd be left with 3x plus 2. Now the second fraction, between 12x and 8 we can take out a 4, so we're left with 3x plus 2. Okay, now once you get good at this, you'll start using this method here. This is actually how I do it when I add fractions because I don't really need to write out what is the lowest common denominator. I just look at it, both denominators in their factored form, and figure out what pieces of the denominator are missing in each fraction, and then multiply them by those. So, for example, this first fraction, let's rewrite it. Okay, the lowest common denominator is going to be the product of all these factors down here. Now they both already have a 3x plus 2, so that's taken care of. However, this first fraction has an x and the second fraction does not. And the second fraction has a 4 while the first fraction does not. So what's missing in this first fraction is this 4. So we're going to need to multiply this first fraction by 4 over 4. And the second fraction, then we rewrite it. So the piece it's missing It has the 4 and it has the 3x plus 2, but it doesn't have this x. So it's going to need an x in its denominator, so we'll multiply it by x over x. And then simplify from here. So multiplying these first two fractions together, we get 16 over. I'm just going to reorder this denominator and write the 4 out front. So 4x times 3x plus 2 minus, this fraction gives us 3x squared over the same thing. I'm going to bring this x reorder, put it over here. So 4x times 3x plus 2. And so now we have a common denominator. And so we can subtract the fractions. So we have 16 minus 3x squared all over 4x times 3x plus 2. And the next question is, does anything simplify? And between 16 and 3x squared, we can't take a 3 out of 16. It's not a difference of two perfect squares, so there's nothing we can do to factor further. So this is our final answer right here. All right, and let's try that same method on this one. So on this one, we start by factoring. So we have 6x over, in this denominator we have, let's see, it looks like that may be a perfect square. If we factor it into x plus 2 times itself, that gives us x squared plus 2x for the outside and inside term, which do add to 4x, and plus 4 for the last term, so that works. Plus x over, x squared minus 4 factors into x plus 2 times x minus 2. Okay, so all I've done is factor each denominator, but now again I can see which fraction is missing which piece of what's going to be the common denominator. And it looks like the first fraction, let's see, it has 2x minus 2's, and it has no 2x plus 2's, but it doesn't have any x minus 2's. So we're going to need to multiply this first fraction by x minus 2 over itself. And I'm going to do this in one swoop here. And actually this denominator, this right here, x plus 2 times x plus 2, we really should write that in its more simplified version of x plus 2 all squared. Now we're multiplying this first fraction by the piece it's missing, which is that x minus 2 over itself. Notice I'm not writing it as a separate fraction because that's not really necessary. Plus x over, now on this one we have an x plus 2 and we have an x minus 2. So I'll start with that. What we need is another x plus 2 on this second term because we have one of them, but this one has 2. So we're going to multiply this one by x plus 2 over itself. And then simplify from here. So this first one, if we expand that out, we get 6x squared minus 12x. Now we're adding, so plus all of this, x squared plus 2x. All over x plus 2 quantity squared times x minus 2 because they have the same denominator. Although they're not written the same, this is x plus 2 all squared. And let's see, we have 6x squared plus x squared gives us 7x squared. And negative 12x plus 2x gives us negative 10x. So the next question is, does anything simplify? Now we can take an x out of the numerator. If we do that, we're left with 7x minus 10. And so it's clear nothing else is going to simplify here. So here's the fully simplified version. Okay, so that's it for adding and subtracting rational expressions with different denominators. Okay, tune in next time to section 7.5.